So we're making an MMO, but it doesn't really look like one at the moment. In this video, we're going to turn it from this into this. In order to make that happen, we'll need to give the game a fresh coat of paint, implement chat, and implement player movement and some other things like maybe emotes just to make it a little bit more fun. This is a learning project we're working on, so in order to keep our costs down, we're just going to use pre-existing assets. We're building a Western-themed MMO, so this Synty polygon pack will give us everything we need. So that's been grabbed and we've pretty easily set up our player prefab, but their movement at the moment is just zooming around in a T-pose. So our next step is to implement our actual movement and animation. For this MMO, the main way that players are going to be controlling their character is by clicking where they want to go and having the character walk there. So we're going to implement Unity's pathfinding to get that all up and working. Again, pre-existing libraries and tools make things very easy to get up and running quickly, so that's good. When the player clicks the screen, we fire a ray from the camera to find the closest point to the ground to where they've clicked and move the player to that point. Then the Unity pathfinding system will find the way from where the player currently is to where they need to go. This is the real strength of Unity, the fact that it comes with so many simple plugins and libraries and tools on the asset store that you can use to get things up and running really easily without having to worry about it too much until you need to get something a bit more custom and bespoke. Next up, animations. Our player's already moving, so we can pretty easily get our speed from that, pass that speed in to detect if the player's walking or idle, and the animator can just switch between a simple Mixamo idle and walking animation. Done. Boom. Finally, we need to implement a simple camera follow so that we can explore our world a little bit more. Using Cinemachine, we've got our camera following our player, and we've even implemented a nice little zoom, so the player can zoom in and see themselves in detail or look at the world a bit more up close if they want to, I guess. This is going to be great when we've implemented character customization, so the player can zoom in nice and close to get a screenshot of themselves using their custom outfits and whatever that they've found around the game. Whenever we add a new feature to our MMO, we need to stop and spend some time thinking about how we want it to function in a networked environment. What information do we want to be sending over the network? How computationally expensive is that going to be? And what pieces could we get away with doing just locally on the player's end to simplify things? Let's consider player movement. The player movement is broken down into the player clicking and moving, the movement animation that tracks things like speed, the actual position of the player on the screen. So we could synchronize any or all of those pieces, really. But synchronizing the player's position and animation data is probably a lot of data, especially if there's going to be a lot of players, which in an MMO there could be. If we're doing more complex physics-based movement, we might need to do this because it might be vitally important to know exactly where a player is at a given time. But for our game, the players don't collide with each other. They're moving around a space and interacting, but not physically. So we don't really need that to be all that accurate. So instead, all we really need to send is if a player is trying to move to a position. Each local client can control whether that player is moving and how they move and their animations. And all we really need to know is, effectively, a simple vector 3 that says, I want to move to this position, and then each client will control that independently. It won't line up perfectly, but it doesn't have to. As long as the player roughly ends up in the same position that they're meant to, everything will go pretty smoothly. That way, we're just sending quite a small amount of data through the network, and each client handles its own animation, and it all goes pretty nice. We've got our game looking a lot better, and you can walk around, but we need to let our players actually communicate with each other. Right now, it's pretty lifeless. So let's implement chat. We've used out-of-the-box solutions before. Photon, who is implementing Photon Fusion, which is the backend that we're using for our server, they even have their own system for this, I think, Photon Chat. We could use this or some other chat solution provider, but again, it's a learning project. I think let's roll our own solution, let's learn. Time to learn about sockets. In our last video, we talked about different types of communication and how different parts of the game would communicate with each other. We said that the back end of the server would mostly be used for slower communication. And this is true, but that mostly is doing some heavy lifting there. Previously, we've talked about simple HTTP requests where we send a request to our backend and we get a response back. So we might say, I'm logging in, and the backend says, yep, you've logged in, good job. This is perfect for those types of requests, but we do need some quicker back and forth type communication for things like chat or for getting messages that we haven't explicitly asked for. So The other type of communication that will facilitate this for us is sockets. Sockets will allow us to communicate with our backend more frequently and in real time, which is something that both the client and the server will end up needing. Chat is a perfect example of this. We don't want to have to send a request to get all of our latest chat messages. We'd have to be sending a request every few seconds just to see, are there any new chat messages for me to receive? What we want is for the backend to tell us directly when we have a new chat message. And the best way to do that is by using something like sockets that maintains a constant connection. As a little side benefit, this is quite nice for us to do things like detecting if a player is online. If you want to send a direct message to a player, we can, on the back end, check, do they have a socket open? If yes, they're online and you can send that message. Okay, so all the pieces are in place, but how does this actually work? When I send a message on the client, when I hit send, that message gets bundled up into a little socket data packet that is pushed through my socket connection to the backend. The backend then is maintaining a list of which players are online and managing their lists of sockets. In the future, we'll break those sockets down by room as well, but for now it's just a big list of who's online. When my message comes through, the backend takes that message, does a little bit of transformation on it, and then pushes it out to every other player's socket. So that means when I send a message, it goes to the backend can log it or verify it or do some things like chat filtering to take out swear words if we want, before sending it off through to every other player. In that way, I'm sending a message kind of directly to each other player, but it has to go through the backend first for some validation. That will make sure that things like somebody sending a message but saying it's coming from somebody who isn't them can't happen. It's a security measure, I suppose. We don't want people to be able to, for example, imitate an admin and send a message as if they were an administrator in the game. So, when a client or server starts up, it should also connect a socket to the backend. That means it's ready to send and receive chat messages. C# has some pretty nice socket libraries we can implement, so we're basically just wrapping some things around those. All we'll need is a few pieces of data for things like, what type of socket message is this? Is it a message that I'm just posting that goes to everyone in the room? Is it a DM? Is it something else? And of course we need, what is the actual message? We'll probably include who is sending the message as well, so we can display that. We'll also need to make some UI in order for us to send and receive these messages, so we'll quickly put that together as well. It's a bit ugly, but fear not. Again, we'll be improving UI and things in future videos. And just for good measure, let's also make it that when we receive a chat message, we also display it above the head of the user who said it, so you can actually see it physically coming out of the character that has sent that message. So yeah, chat, done, boom. The chat interface is also a pretty good way for us to allow the player to perform emotes. I've always loved that old school MMO style of allowing you to type in text, a slash command to do an emote, like, slash haha, slash lol, slash dance, whatever. It's very old school MMO, which is kind of the vibe that we're trying to go for. So let's set up some simple ones. On Mixamo, we can just grab a few animations. Let's grab a wave and a Fortnite dance type thing. And if our chat system receives a command like slash wave or slash dance, it will know to turn it into an emote. Instead of popping it above the head of the player and treating it as a typical chat message, it will just make that character do the requested move. Our MMO now is starting to look a bit more like a real MMO, but there's not really any gameplay in here yet, so we'll have to work on that next. And by next, I mean in our next video, so stay tuned.